Hi guys, we are doing section 1.2. Your homework is listed on the page here. When you see EOO, that's every other odd, okay? So you're going to do number 1 and skip number 3, do number 5 and skip number 7, like that, so that you're doing every fourth problem. And there's quite a few of them in there. That leaves the other odd problems if you feel like you need more practice. Okay, what we're working on is linear equations. Linear equations in one variable. What does that mean? Well, here we go. Linear, the word linear, means that your variable is only going to be to the first power, and we're only going to have one variable. You're used to seeing most of the time an x. Every now and then it'll be t for time or s for distance, something like that. It doesn't matter what the letter is that represents the variable value. You're just, whatever's there, that's what you're working with. And in these problems, it's just to the first power. If it was to the second power, we would call it quadratic. And then anything above that is just of higher degree, degree meaning the highest power. Okay, so let's get started. First off, these two things right here, we need to be able to recognize the difference between an expression and an equation. What's the difference? An equation has an equal sign, right? With an expression, all you can do is simplify, and in this case, this is as simple as it gets. All you can do is simplify, but with an equation, you can solve for the variable. What we're going to be doing in this section is this, and it's a lot more complicated than the thing that I just wrote down, just saying. So here we go. So your strategy for solving a linear equation, that means there's an equal sign, is that you have to simplify both sides of the equal sign. How do you do that? You've got to use the order of operations. Now I know all of this should be review. Hopefully it is, but this section does have a lot of rational expressions. Rational means ratio fractions, and you'll have to be finding common denominators, which will in some cases require you to be able to factor polynomials. And that's all stuff that you were supposed to have mastered before you got into this class. If not, we'll be going over it as we work through this section. So you simplify both sides. Then you're going to have to get all the variables on one side, and this is not the textbook way to write this, but it's the way we understand it. Get all the x's on one side. That means on one side of the equal sign. And then you get them alone. That means you get rid of any of the constant terms, and then you divide the coefficient away. Divide both sides by the same thing. And I will explain each of these steps as we move through. Okay, for example, let's say that we have something like this. Hold on. Okay, now, first off, when you're simplifying both sides, you want to ignore the opposite side. So if I'm simplifying this side, I'm not looking at this at all. I'm focusing just on this. Order of operations says do inside the parentheses. Well, I can't combine these terms because they're not alike. So I have to work outside the parentheses in this case. So please excuse my dear Aunt Sally, right? You guys learned it as PED mass or whatever. Please excuse my dear Aunt Sally. So we're going to work forward through the order of operations to simplify, and then actually to solve, we're going to go backwards. We're going to get rid of the addition and subtraction. That will be getting our x's alone, and then we're going to get rid of the multiplication and division, which will be dividing both sides by the coefficient. So the first thing we're going to do is look inside the parentheses on just this side. I can't combine. Then there's no exponents. Now I want to take care of any multiplying or dividing that's going on. See that minus sign? That minus sign is touching the parentheses. That means everybody inside the parentheses is being subtracted. And I can write a 1 right there. And it helps me see that I have a distributive property problem here. I'm going to distribute not just the 1, but the minus 1. This is the number one mistake that I see, is not distributing that minus to both pieces. So watch yourself, make sure that it goes everywhere. The 5x, I'm going to subtract the 2x and subtract the 3. Now I can combine like terms, 5x's minus 2x's, and I am as simple as I can get, and my equal signs are still where they were. Now on the right hand side, I've got brackets with parentheses inside. I start on the inside of the inside. I can't do anything in here, so I go out into the bracket. Inside the bracket, I have multiplication of, you see how the 2 is touching the parentheses, but the minus is touching the 2. So the whole thing, negative 2, gets distributed. Be very careful. So the 4 in the bracket and the 3 stay the same. I distribute the minus 2 to the x and the minus 2 to the 1. And now inside the brackets, I combine like terms. So I've got a positive 3 and a negative 2, which combine to be a positive 1. So I've got a negative 2x and a positive 1. And now the last little bit is to distribute that 4. So I have negative 8x's, positive 4. And that equals 3x minus 3. Now, the next step is once I get it simplified, now I start to get my x's together. So, by the way, over here in my little thought bubble, if I have 3 equals x, then I have x equals 3, right? So it doesn't matter which side I move my x's to. So I know, and you know just as well as I do, that minus signs always mess us up. So you see how this guy right here, I have minus 8x's over here and positive 3x's over here. I want to move these minus 8 to the other side, which means that I'm going to add 8x's to both sides of this equation. So that's going to give me positive x's. And it doesn't matter what side I'm moving to. 3x minus 3 equals minus 8x plus 4. You guys probably can't see the bottom of this where I'm writing, so there you go. So I want to add 8x's, add 8x's. By the way, if you don't simplify first before you start moving things from one side of the equal to the other, you're going to end up accidentally, say, adding 8x's twice to the same side of the equal sign, something like that. So you must simplify completely before you start solving the algebra problem. Simplify first. It's the most important step. Make sure that you distribute all your minus signs as well. So notice that equal sign is in the middle, and 8x equals 8x, right? So adding on the left-hand side, 3 and 8 is 11 x's, and we are left with a minus 3, and that's going to equal the 8x and the positive 8, and the negative and positive cancel, and we're left with the positive 4. Now we want to add 3 to both sides. Notice the equal sign's in the middle. We have an 11x equals 7. And now the last thing to do is to get rid of that coefficient. The opposite of multiplying is dividing. And I end up with 7 over 11. Okay, here's our next problem. I actually had trouble getting it to fit because I started writing too big in the first place. All right, find your equal sign. Here it is. So we have to focus on just one side at a time. On the left-hand side, I have brackets, so I'm working inside the brackets. I can't do anything to these parentheses, but I see that the minus 4 is touching. That means multiplying. So I have 45 minus, because we're dealing with linear equations, we are lucky we don't have any exponents right now. So distributing the negative 4 gives me negative 4 times the y, and negative 4 times positive 7 gives me that. Now, inside the brackets, I combine like terms. The minus is still on the outside, guys. So how many y's do I have? I have negative 2 of them and negative 4 of them, which combine to be negative 6 of them. And I have a 4 minus a 28 gives me negative 24. If you struggle with subtracting like that, just think in terms of money. If I have $4 in my account and I spend 28, then I'm going to be owing $24, right? All right, next, distributing that minus sign. Again, you see there's a 1 right here. So distribute that negative 1 through the parentheses, and I'm going to get positive 6y, positive 24, keeping my equal sign right there. Now combine like terms. I'm going to have 6y's and a positive 69. All right, now if we were in a classroom and I did that wrong, you would catch me, right? So if I make a mistake, I'll go back and fix it later. Okay, on the right-hand side, this is a little bit more complicated because we have parentheses here. We can't do anything in there. So the first thing I'm going to do is distribute the minus 4. But we have brackets over here. Now these parentheses and these brackets are separated by subtraction. So I can work both pieces at the same time. Inside my brackets, I have these parentheses and these. Nothing can happen inside. So I'm going to distribute the 3 and distribute the minus 2. These are completely separated, so I can do both at the same time. So here's what I end up with. Distributing the minus 4 gives me negative 4 times 1. Negative 4 times positive 3, y. Minus on the outside of the brackets, because I'm working inside. I have a 4, distribute the minus 3, distribute the minus 2, gives me positive 10 at the end. And now inside my brackets, I have to combine like terms. The minus is still outside. Do your y's first. I have minus 3y's and minus 4y's, which gives me minus 7y's. And then I have a 4, a negative 6, and a positive 10. So if you keep the sign in front of the number, I can put my positives together. That gives me positive 14 minus 6 is going to give me positive 8. Now, inside my brackets is simple, so I distribute my minus sign. So I have negative 4, negative 12y, plus 7y minus 8. Make sure you distribute it all the way through. It's like distributing a minus 1 right there, right? So, now combining like terms, I have negative 12y's and positive 7y's. leaves me, wait a second, sorry, black ink. I have negative 5y's, and negative 4 and negative 8 give me negative 12. And now I'm at the point where I can move things from one side to the other. So I want to add 5y's to both sides, which is going to give me on the left-hand side 11y's. Now, I don't want to have the plus 69 over there with that, so I'm going to subtract the 69. I can do both things at once. Once I get used to it, I know what's going to happen, right? My equal sign is in the middle. Notice that 5y minus 69 equals 5y minus 69. So I'm making sure that I'm doing the same thing to both sides of the equal sign. The equal sign represents a balance. And as long as I do exactly the same thing to both sides, I can do whatever I want, right? So on the right-hand side, the 5y's are subtracted. Negative 12 and negative 69 is going to give me negative, hold on, adding that, I hate nines, I really hate nines, 81. And now you divide both sides by your coefficient. You had the negative 81 and you divided by the 11. And by the way, always, always, always reduce fractions to lowest terms every time. So 11 and 81 don't have any common factors, so I'm done with that. Okay, so here we have something a little bit different. We've got rational terms in this equation. So we need to make sure that all of our terms have the same weight. In other words, their denominators have to be the same. For instance, if I have 3 5s and 2 1s, I can't say that I have 5 bills. That's not how you count up the money, right? The $5 bills have a different denomination than the ones do. Same thing with rational equations like this. So we have to find the common denominator and make all of the denominators the same. So I have a 5, a 2, and a 3. You guys know how to do this. My least common multiple, we want to keep this as small as possible, but all of these numbers are prime. So we just multiply them out and we get 30. This is something that we need to practice. So make sure that you do all of these problems and work on them until you get them right. I think the problems with the numbers in the denominator are harder than the problems that have polynomials. Because with the polynomials, you factor them and you just make a list of factors. And it's quite simple, actually. So here we go. If I want to make all of these problems have the same denominator, then I'm going to multiply the top and the bottom by whatever number I have to multiply by to make them the same number. So I'm going to rewrite this problem. That was not a 5, was it? Rewrite this problem and go back and multiply by whatever I need to multiply by to make the bottoms all 30s. So for the first fraction, I have 5 in the bottom. I need to multiply 5 by 6. If I do it to the bottom, I have to do it to the top. A 2 gets multiplied by 15. Got to go both ways. The 3 gets multiplied by a 10, bottom and top. So now I'm going to rewrite the tops. 3 times 6 is 18 x's. This is over 30, right? And now a negative 15 gets distributed through the x minus 3. That's over 30. And a 10 gets distributed through the x plus 2. And that's over 30. Now, if all of these denominators are the same, then I don't really care what the denominator is. My equation is now in my numerator. So I can make this one fraction on the left, one fraction on the right, and frankly, if I multiply both sides of my equation now by 30, I'm keeping my equality because I'm doing the same thing to both sides, and multiplying and dividing by the same number is just multiplying by 1. So you see that the equation is only in the numerator in the first place. And we end up with an equation that's just like the ones that we've been doing. All right? So we're going to redo this problem in a second in a much easier way than what I'm showing you right now. We just need to cover our bases and make sure that we understand why we can do this. So, simplifying by distributing the minus 15. Minus times a minus is a plus. 3/15 is 45. Distribute my 10. On the left-hand side, I have to combine like terms. I get 3x plus 45 equals 10x plus 20. And now I'm going to get my x's together. Watch me. I like to take the smaller number and get rid of it. My x's are going to end up on the right-hand side, but that's okay, right? Now, you see that these will go away, and I'll be left with x's on the right. So I'm going to get rid of the number on the right. And you see that minus 3x minus 20 equals minus 3x minus 20, just making sure I'm doing the same thing to both sides. So on the left-hand side, 45 minus 20. On the right-hand side, 10x minus 3x. I divide, and I get x equals, sorry, hold the phone. It doesn't matter what side the x is on, right? I'm dividing by 7. I get 25 divided by 7 as my answer. Are we good? All right, you can always check these answers by plugging them back in. It's just that my examples that I'm giving you, I always end up with these nasty fractions. You don't always get nasty fractions. So I want to show you very quickly how to work this same problem in an easier, quicker way, doing the exact same thing that we did before. We know that our common denominator is 30. So what I can do is I can take my left-hand side and multiply by 30. That 30 is over 1. This 30 is going to get distributed. I'm writing every step here so you can see it. Let right-hand side gets multiplied by the same thing. And now that gets distributed, that gets distributed to both pieces. Every piece gets multiplied by the 30. So what I end up with, and I'm going to write this step out so you can see it, 30 over 1 is going to multiply 3x over 5, and switching to red, 30 over 1 is multiplying x minus 3 over 2, and I'm subtracting, and I have an equal sign, x plus 2 over 3, and that gets multiplied by 30, I'm running out of room here, guys, 30 over 1, right? So we can see that. Now, what happens? I cancel. 30 on top, 5 on the bottom leaves me with a 6. 30 on top, 2 on the bottom leaves me with a 15. 30 on top, 3 on the bottom leaves me with a 10. What do I get? I get the exact same thing that I had right here. I get, I get 6 times 3x, no more denominators, 15 times x minus 3, and 10 times x plus 2. Okay, so my goal for you is to start right here with this. See that the common denominator is 30. Write a 30 here, a 30 here, a 30 here, cancel, and write this step. And once you understand why it works, which is the biggest benefit of writing out the steps a few times, once you understand the why, then the how and the what become easy. So just simplifying, minus 15x's plus 45, and we get the same thing we had before. Let me just make sure I get the same answer. 3x plus 45 on the left, 10x plus 20 on the right. Get my x's together by subtracting 3 from both sides. Get my numbers together by subtracting 20 and divide by 7, right? And that gives me x equals 25 divided by 7. Booyah. Okay, now we have one that's a little bit different. It's going to be the same concept. Find the common denominator, multiply both sides of the equal sign by that. It gets distributed to each fraction, and your denominators will all cancel away, and you'll have a simple equation that's in the numerator. Now, I said earlier we were working on linear equations, and in this case, I have an exponent. That's okay. Once we simplify this and get rid of our denominators, we'll be left with just x to the first power. So first step is to simplify, right? Well, that requires that we be able to factor all of our denominators, and this is the only one that we need to factor. So the first times the first is x times x. You guys should be good at factoring at this point. Now, there's no coefficient, so it's pretty easy. You know, you just have x times x when you FOIL that out. To get the guy in the back, we're multiplying two numbers to get a negative and a 6. The negative means that these guys are going to be opposite signs, so we're subtracting the factors of 6. When we do our outers and our inners, it'll be subtraction to get a positive 1. So I'm going to write this down really quick. We need the factors, just as a reminder, the factors of 6, and it's negative, so that subtract to give us a positive 1 in the middle. So that's the way we undo this puzzle. The factors of 6 are going to be a 1 and a 6, or a 2 and a 3. We want to subtract to get 1, and it's that way, and it has to be a positive 1, so the 3 is a plus, and the 2 is a minus. So this is a minus 2 and a plus 3. It doesn't matter which one you write first, as long as the 2 is negative and the 3 is positive. Now, math is cool because you can cheat a little bit. Notice that we had this factor and this factor. That kind of told us what we needed. So if you're going to cheat that way, it's a good kind of cheating, guys. Multiply this times this and see if you get this. Sometimes you don't, and then the problem's really complicated. But in this case, we did. So what's my common denominator? It's just a list of all the factors. So my LCD, I'm going to go through with the first fraction. I got an x plus 3. The second fraction, I got an x minus 2. And the third fraction had both of those. So I know that I'm right. So I take that guy and I multiply the first guy by x plus 3, x minus 2. It doesn't matter what order you write them in, it's multiplication, right? Multiplying each piece because I'm multiplying both sides of the equal sign and then distributing through each side. So if I wrapped this side up in parentheses and multiplied by that, and remember that's over 1 with brackets, then it would get distributed here and distributed here. So I know that I'm doing the right thing because the distributive property. Now, x plus 3 cancels x plus 3. Remember, this is over 1, right? X minus 2 on the bottom, x minus 2 on the top. Both of these cancel both of these, and I'm ready to go. I have a 6 and an x minus 2 left over. I have a minus sign, a 5, and an x plus 3 left over. I have an equal sign, a negative 20, and nothing left over. So, very simple linear equation with no denominators. 6x minus 12, negative 5x minus 15 equals negative 20. Combining x's on the left, combining the numbers on the right, on the left, I'm going to get rid of that minus 25 by adding it to both sides. And now I'm not quite done because I had variables in my denominator. I have to make sure that when I plug this into my problem that I'm not dividing by 0 anywhere up here. So the easiest way to do that is to go to your LCD. If I plug a 5 in here, it's not a 0. Plug a 5 in here, it's not a 0. That means that I have gotten a good answer. Now you can always plug the 5 in and check and make sure both sides are equal to each other. And the best way to learn how to do these problems is to check your work. So go for that. I'm going to do one more and then you're on your own, guys. All right, here we go. Now we have 3 denominators that have to be factored. Once we factor each of the denominators, we're going to write down our LCD, which is just going to be a list of all of the individual factors that are in the whole problem. So here we go. Let's do this in blue. All right, first times the first gives us an x. The last times the last gives us a minus 10. So when we FOIL this out, the first times the first gives the first. The last times the last gives us this guy. But notice that when we do the outers and the inners, I'm going to get x times one of the factors of negative 10 and x times the other factor of negative 10. And those two guys are combined to give me plus 3 in the middle. So I need to factor 10 in a way that I can subtract to get a positive 3. So those factors of 10 have to be a 2 and a 5, right? So a 2 and a 5, and they're going to subtract to be positive. So the big number is a plus and the little number is minus. All right, let's try that again. The first times the first is x squared, so it's x times x. The last times the last is a 6. But the factors of 6 are going to combine by subtraction, because that's a negative back there. My signs are opposite. They're going to combine to give me a positive 1. So if 1 and 6 don't work, I have to use 2 and 3. And they're going to subtract to be a positive, so 3 is plus and 2 is minus. Last one. Factor, x times x. The factors of 15 that add, so they're both of my signs are going to be the same, right? So this is either a plus or a minus, and this is the same as before. So they're going to combine to be a positive number, which means they're both pluses. And the factors of 15 that add to be 8 will be 3 and 5. Now my LCD is just a list of those factors, so use your finger. You're going to start by writing x minus 2. Don't make this harder than it has to be. You're going to copy the x plus 5. Just making a list, guys. Next, I have an x minus 2, but wait, I already wrote that. I don't write it again. I have an x plus 3. Moving on to the next factor, that we did the x plus 3, now we're here. I've already written that. I don't write it again. I've already written this. I don't write it again. The point of an LCD is each of these denominators has to be in here. So the first one is these guys. The second one, x minus 2 times x plus 3, is this times this, so it's there. And the last one is these two guys. You see it right there, right? So all of my denominators are in my LCD. So what I'm going to do is I'm going to wrap up both sides of the equation and multiply by my LCD. So I have this guy in factored form here. I've got these two guys over here, x minus 2, x plus 5, just showing you what's going on here. And I have 1 over x minus 2, x plus 3, and that was subtraction. And I'm going to take my blue LCD, x minus 2, x plus 5, x, these are multiplied, I just ran out of room here, x plus 3, and I'm going to multiply both sides of the equal sign by that. But on the left, you see this thing is touching the brackets, which means it's going to distribute to each of these pieces. So I'm going to actually go ahead and distribute those. You can do this every time. As a matter of fact, once you've done this a few times, you don't have to write down the step that I'm writing down right now, because you'll see that if you're multiplying all of these fractions by this common denominator, each of these denominators is going to cancel. That's the whole point. So when I multiply the LCD by this guy, these two pieces cancel, and the other guy is going to survive and multiply what's on the top. So practice doing what I'm doing right now, and you'll see that every single time you're left with one factor. And then you can just write down what's left, what doesn't get canceled. So I have the 4 that was there and the x plus 3 that was not in my denominator. I have a minus sign, a 1, and an x plus 5 that wasn't in my denominator. And I have a 3 and an x minus 2, which wasn't originally in my denominator. So all of that writing and all of that work is actually something very simple. It's your numerator that you started with times the missing piece from the denominator. Everything else gets canceled away. So now I have 4x plus 12. Distribute the minus all the way through. Distribute your 3. On the left-hand side, combining like terms, I have 3x and 7. And this leads me to the next thing I want to show you. Notice that when I get my x's together here, subtract 3x from both sides, what happens? They're gone. And I'm left with 7 equals minus 6. When is that true? Is there a value of x that will ever make 7 equal negative 6? If you get a situation where your x's cancel and you're left with something that's not true, your answer is no solution. What if you were left with 7 equals 7? That's always true. So your answer would be all real numbers. It doesn't matter what x is, except none of these factors could be zeros. So your answer, if you got perfect 7 equals 7 instead of this, then you would write all real numbers except x can't be 2, x can't be negative 5, and x can't be negative 3. And you'll see that quite a few times as you're working through the problems. So this is never true, so it's no solution. But if you get a true statement, then anything that's in the domain of the problem is your answer. All right, good luck, guys. Your homework was on the front page of this video. Go for it. If you have any questions, you just ask me.